Hello and welcome to this short video where we'll be finding the 6 trig functions sine, cosine, tangent, secant, cosecant and cotangent within this unit circle which I have constructed here. I've already done all the drawing and constructing required to find all of these 6 functions, and I will now explain to you what I've done. So I have first drawn this unit circle here. You can tell it's a unit circle because it's centered at the origin and has a radius of 1. So I've drawn this unit circle and I've selected a point on this unit circle P such that P is cos theta comma sine theta. So therefore the angle from the horizontal, the x-axis, and the anticlockwise direction to the point P is theta. I've also labeled some other angles which are also equivalent to theta. This angle is equal to theta, which you can find by comparing this triangle OPQ and this triangle ORP and PQR. Using these 3 triangles we can be clear. This is 90 degrees minus theta. This total angle is 90 degrees, and therefore this extra angle here is theta degrees or theta radians. Similarly, this whole angle is 90 degrees or pi by 2 radians. So that means this angle is pi by 2 minus theta, which means this angle is theta, since this is a 90 degree angle. So now that we have that constructed and I have labeled the points P, Q, R and S, let's start to look for the sine, cosine, tangent, secant, cosecant and cotangent functions within this diagram. So immediately what we can see is that the horizontal distance here and the vertical distance here can easily be identified as cosine of theta and sine of theta, because we have this triangle here, and given this triangle and this angle theta, the opposite side within the OPQ triangle is the PQ side, and PQ side divided by 1 is sine theta, so PQ is sine theta. Similarly, the adjacent side to theta here is OQ, so OQ divided by 1 would be cos theta, so OQ would be cos theta. So immediately we can write that PQ is sine theta in this diagram and OQ is cosine theta. Now let's look for the other ones. How about tan theta? Consider the triangle OPR. Within the triangle OPR, we have this side length here, which is 1. We have a 90 degree angle going like this, and we have a horizontal going like this. This is 90 degrees, this angle is theta, this is O, this is P and this is R. In this triangle, considering the side lengths PR and this side length OP, which is 1, tan theta would be PR divided by 1. Therefore PR is tan theta. Tan theta equal to PR divided by 1. Therefore PR equals tan theta. So from this it's clear that PR is tan theta. I'll go up there and write this in that same place that I wrote the other two. I'll go up here and I'll write PR equal tan theta. Now the other ones, the secant, cosecant and cotangent. The secant line is actually the line OR. We can see this clearly again if we consider the triangle OPR. Considering OPR once again, we have O, we have P, we have R, we have a 90 degree angle here and a length of 1 here. If we consider the cosine of theta within this triangle, it would be the length OR divided by 1. So 1 divided by length OR. Cosine of theta is length of the adjacent, which is 1, divided by length of the hypotenuse, which is OR. So cosine theta is 1 over OR, meaning OR is 1 over cosine theta, and 1 over cosine theta is what we call the secant of theta, sec theta. So here what we mean by the secant line is the line OR, therefore OR is the secant of theta. OR is sec theta. As for the cosecant of theta, that is the line OS. It's the length from the origin up to the place where the tangent touches the y-axis. So OS is cosec theta, cosecant of theta. We can show this again if we just construct the OPS triangle. Constructing the OPS triangle like this, it is like this, and this angle here was theta, and from this and this being 90 degrees and this being 90 degrees, we can say that this angle is also theta. This was O, this was P, and this was the point S. This side length OP had length 1. Considering sine theta here, sine theta is opposite divided by hypotenuse, which is 1 divided by OS. So therefore OS is 1 divided by sine theta, and 1 divided by sine theta, or the one inverse of sine theta, is what we call cosec theta. So cosec theta. Therefore OS is the side length cosec theta. And as for the cotangent of theta, it is the other one other than the tangent of theta. Tangent of theta is the length PR. Cotangent of theta is the other part of the tangent, SP. So we can show this again using this triangle. Considering this triangle, if you take tan theta, tangent of theta is this divided by this. So therefore tangent of theta in this triangle is 1 divided by SP. So therefore SP is 1 divided by tangent of theta, which is what we call the cotangent of theta. So you can kind of see where these functions get their name. PS is the cotangent of theta. So here it kind of makes sense. I mean, some of these also make sense, and a lot of students will learn this arbitrarily. I think this is a good way to actually understand what these functions are and what they mean. The tangent and cotangent are very easily understandable, I think, when you draw it like this. You just draw the tangent at the point P, and this length of the tangent is tan theta, and the other part of the tangent is cotangent theta or cot theta. I think that's very clear. And I think the other thing of OR, this length being the secant of theta, and the other length being the cosecant of theta, which is like the other secant of theta, is very clear when you look at it like this. The secant is this line OR, and the equivalent cosecant, the other secant, is OS. As for sine and cosine, you kind of have to just look at this triangle and understand that one. But I think now that you have seen it and done this construction, and I would recommend that you yourself also take a compass and a ruler and do this construction and figure out these lengths of these lines and understand what each of these trigonometric functions actually is, what they represent within the circle. So you can of course use this method. If you have a protractor, you can draw any arbitrary angle that you want, and then you can actually physically draw these lines, measure their lengths, and calculate the tangent, cotangent, secant, cosecant, or sine or cos of any angle that you want. And I would encourage you to do so as well to better familiarize yourself with trigonometry and understand the beauty behind trigonometry. So that's it for this video, and thank you for watching, and goodbye.